Hello everyone. So to get started with our Unreal Engine project, we're going to be opening a blank project in 5.1. So when you open up the engine, it'll be on your recent projects. Just go to Games, Blank Project, Started Content Enabled, name it what you want, and then it'll open up into this window. So the way we're going to do this is we're going to do everything in Unreal first, and then we'll shift over to Blender later on to do replacement stuff. So Unreal first, then Blender. So I don't really like this particular setup myself. I like the way UE4 looked. So if you go to Window, you can load the old layout, or you can stick with this one. I like the old one better. I don't like that slide in out drawer thing with the control spacebar. I like this one better personally. Alright, so now in our content folder, I'm going to right click, create a new folder. This is going to be my main folder. This will be what holds all our stuff. I'm going to double click and open it up. And the first thing we will need is a game mode, so we can kind of customize a little bit of the stuff about our game. So I'm going to right click, blueprint class, game mode base, and this is going to be FP dungeon underscore GM, since we're doing first person dungeon. Now we will need a player controller. So right click, blueprint class, player controller, FP dungeon underscore PC. I'm going to open up my game mode. And over on the player controller class, I'm going to set that FP dungeon. I'm going to dock this up here real quick because we need our player character. So I'm going to right click, blueprint class, character. This will be player underscore BP. So now we have our character that will actually control, the player controller we'll use, and our game mode. I'm going to double click and open up the player. Head over to the game mode real quick so that we can go back into the class defaults and set the default pawn class to our player blueprint. So class is default pawn, player blueprint, boom, and that's how you determine which starter character you'll use. Because if you just jump in and press play, you're just this flying around thing. So now that we have all that set up, we need to actually tell the project that's the game mode we want to use. So I'm going to open up this little drop down. Under project settings, game mode, you can set which one you want to use. Select game mode base class. There's my game mode. So now you'll see I'm hurtling to my death. That's because my character has gravity now, whereas before he didn't. But I can't move at all, can't look around, can't do nothing because it is completely empty. There's nothing. This is a completely blank project. So we will go into edit. We're going to go set up some input commands under the project settings. So under the engine, you will find input. I don't know enough about the enhanced input actions yet to do anything with that. So I'm going to use the action and axis mappings of yonder days, but it'll work just fine. And then we'll go back and look at something later on about the other. So I'm going to set up some axis mappings. So I need 1, 2, 3, 4. First one is move forward. It'll handle moving forward and backwards. We're going to set up another one that is move right. It'll handle right and left. Then we'll have look up and look right. So because of the way vectors are coordinated in a 3D environment, a character component will have 3 vectors. It has an up vector, a right vector, and a forward vector. So we can use those to determine, are we moving forward? If we have a negative 1, if we have a 1, then yes. If it's a negative 1, then backwards. So for the move forward and move right, we're going to add one more input. For move forward, it'll be W, and S for backwards, and for the S it'll be -1. So move right will be D, or you can customize this to be whatever input you want, and left will be A, and A also -1. So for look up, it is the mouse movement, so I think it's mouse Y. I always get these confused, so I'm just gonna punch them in right now and then we'll see. If not, I mean, it's easy to go back and fix. So now we have our inputs. We need to go actually tell it what to do. So inside the player blueprint, I'm gonna right click and add my move forward axis event and move right. And we're gonna get player controller and get forward vector. So the player controller is basically the way your character is looking, and the forward vector is basically forward from that. So for move forward, when we push the button, we want to add movement input. We'll plug in our forward vector into this and our axis value into the scale. And just to jump in and take a look, I'm going to... oh no, he's on the ground. Now I can move forward and backwards. Can't move left or right, but we got one down. So now we'll do the same thing for move right, except for from the player controller we will get the right vector. Add movement input. Plug in the right vector, and then plug in the scale. Now we can move forward, back, left, and right. Baby's first steps. We're on the move. So now let's do look up and look right. Now for this one we don't need the player controller. What we will do is we will add pitch input for the look up. So we'll plug this here, because pitch is forward and backwards like the camera tilting up and down, and then for the right we want the yaw, so controller yaw input. Then we'll just plug it in like that, and then we'll check it out. Alright, right and left work, but forward and backward are backward. So in the project settings for the look up, I'm just going to set the scale to -1 so that it inverts my inputs. Yeah, because I like moving up to look up and down to move down. If you like yours inverted, just leave it the way it was, I guess. So I'm going to save everything real quick. So we don't really want to use this environment. It's too much for what we're doing. So I'm going to file, new level, and empty level, create. So it's nothing. There's nothing. Which is what we want. So we are going to go into the starter content and we're going to get a floor for our character to run around on. Once I remember where floors are. Architecture. So we'll drop this just anywhere in the world and I'm going to center it out. Direct center 0, 0, 0. So if yours is dark, I don't know if the lit versus unlit, it might look like this. If it does, just right here there's a lit button. This is the shader, so you can go into unlit and it will light everything up. Or wireframe, but it, oh there it goes. So you can see the tribe and all that. We'll go into the other ones later on. For right now I'm just going to leave it in unlit because we don't have any lighting. Now, if these are how you'll move stuff around, I guess I should sell stuff like that. But if you hold Alt on the keyboard and left click one of these, then you can duplicate your objects. I'm going to assume that you have like at least base understanding. You don't have to be told like where this is, where that is, what these do and all that. So we're just going to stick to the other stuff. So I'm going to control click and select both of these, Alt and click to move a duplicate out. And this looks fine to give our character enough room to run around and do everything for now. I'm going to drag a player start into the world. I'm going to realize that this floor is much smaller than I thought it was. And I'm going to add a little bit more floor space. So I got a 3x3 grid. There we go. That'll be good. Now up here under the lights, I'm going to add a directional light. This acts kind of like a sun, so that we can actually have some lighting in here. So it looks like it's starting to light up a bit too much. So we're going to add a post-process volume. I think I added 2. Sometimes that happens. Sometimes when I drag stuff out, it'll freeze in place, but my mouse keeps moving, and then when I let go, it lets 2 of them in the world. So if it does that, just... See, it looked like it tried to. That was weird. It is... Okay. Anywho, so what we're going to do is go under our exposure settings. And they've replaced the previous settings, I forget what they're called now, but they replaced them with min EV100 and max EV100. I'm going to set both of these to 0. And the exposure compensation, I'm just going to, does that say compensation? Yeah, so I'm just going to click that but leave it at 1 for now. Now in the search, I'm going to search up Unbound for this infinite extent unbound, because the way post-processing works, it applies to anything that's inside that box, or if you click infinite extent, it applies to the whole world. So I'm going to put that under the floor. Then we can go back to our exposure setting and maybe change this a little bit. Nah, I'm just going to leave it there for now, that's fine. What we can do if it's too bright, we can just go to our directional light and then set its intensity, which is up at the top. So about 3, that'd probably be good. Good enough for now. So now we got a character in running around. Let's adjust some of his movement parameters to make it a little bit more realistic feeling. So I'm going to go into the character movement. And I'm going to set his max acceleration to 768. Set his max walk speed to 450. And the braking deceleration to 768. 768, not 86. So the acceleration is how fast your character goes from not moving at all to moving full speed. At 768, I find it gives it a nice little build up to momentum rather than it just being immediate straight full speed. And the braking deceleration does the same thing but in the opposite, so it's how fast you go from full speed back down. I find that 768 just works for both. Play around, see what you like. The max walk speed 450, just personal preference on that also. Depending on your game, you might want them to move faster, slower is the appropriate word. So you just knock that down a little bit further. But everything else right here should be fine. So compile that real quick and jump in, see how the movement feels. Kind of hard to tell without too much in the room, but that's good for now. So now we're going to give our character a little bit of functionality. We're going to give him a sword and a shield. Oh, so we need to save. Let's go into our main folder, create a new folder called levels. Double click and open that up, and this will be dungeon. Okay. Yeah, so now let's go create a little sword for our character to use. So we're going to do this just inside. I'm going to show you how to do BSP brushes in here into static meshes, and then we'll replace them with stuff we make in Blender later on. So under geometry, oh, actually there's the edit mode. Let's go into modeling mode. Let's try this out. So we got a modeling mode now. This is new with Unreal Engine 5. I usually use the BSP brush, but, you know, give it a shot. So let's add a cylinder. Well, oh, detail, okay. So right here, once this pops up, then we can adjust some of this stuff. I'm going to make it smaller. Smaller than that. We'll say 10 for the radius. No, even smaller than that. 5. The height can be 120. Maybe 50. Just kind of play around with it a little bit. See what you like. So 2.5 for the radius and 75 for the height. Let's see how that looks. Good enough for now. Huh. Well, that'll work for a little baton looking thing in the meantime. So now we need our character to have a shield. So we'll do the same thing. We'll add another cylinder that we will change to be 10 units, 2.5 units high by 10 units, 20, 30? 30 might be too much. It's hard to tell in the way we're in right now. But that looks good. So it was 2.5 in height by 30 in the radius. And these are just placeholder. We'll replace these later on with stuff that actually looks like we want it to. But for right now, we just want to attach it to the character. So I'm going to right click the shield and browse to its asset. So it'll create a new folder automatically called generated. This is just my folder, my driver name. And then that's where your meshes that you make with the editing mode will come. So I'm going to rename it to be shield stand-in and the sword stand-in. So sword stand-in. Alright, so let's go in the player blueprint and highlighting the, we don't have a camera. I'm going to add a camera to this, so add a component, camera, move it up into place. Mine is about 60 on the Z, or exactly 60 on the Z. Then I'm going to add a sword mesh. And then you can just kind of position it. One way I like to do it when I'm positioning things and I want it to appear a certain way on camera, I'm going to drag this off to here. And I'm going to drag in one of my player blueprints. And then I'm going to click this little pin preview, because if I have this character selected in the map, his view will pop up right here. And then as I move stuff in the blueprint, I can actually see it in how it'll look in game. So just move that, kind of like that, kind of like if a warrior was running into the dungeon with a sword. So now we'll do the same thing but with the shield. So I'm gonna highlight the camera. The reason I'm attaching this to the camera is so that when we look up or down or look around, the sword and shield will move with it. So back in my generated folder, shield. The reason I select it here first is because when I go to add a component, when I find the static mesh, which is what this is, it'll automatically have it highlighted to be applied also. So I'm going to hit E to rotate it in place, W to go back to transform mode, and then position it where I want it. Let's say about here's looking good. I think that looks fine for now. Let's jump on in and take a look. Looks good. Looks decent enough for now. So you'll notice if you're doing the same thing that you can't look up or down at all. If we come in here, highlight our camera, and then set use pawn control rotation, that'll fix that. So now you can look up, down, etc. Alright, so I'm going to save everything real quick. So now what we need to be able to do is actually swing the sword. So double save everything real quick. So let's add an input. So we'll go into the inputs, and this one will be an action mapping. This one will be attack. We'll have one more that is block, and we'll have yet another one that is interact, so that later on we can pick up stuff or open doors and such. So for the attack, I'm going to be using left mouse. For block is right mouse button. And interact is the E key. Back in the player blueprint, let's go to our event graph. Select everything here. Tapping C on the keyboard brings up a comment box, and we'll just label this as movement logic. So I'm going to right click and add in my attack action event. So basically when I click the mouse button, I want my sword to move and simulate like I'm striking somebody. So what we will do is we'll take its current transform as a rest position, and then move the sword into another position and catalog that as an attack position, and then move to it on a timeline. So I'm going to add two variables here. This will be sword rest transform. So variable, you can click this little icon, it'll add one. I'm going to change it from a boolean by clicking on this drop down to a transform. So I'm going to grab my sword stand in and copy its location. Oh, we have to compile real quick so that we can actually access the variables inside the transform. Right clicking location and pasting, it'll make it to where it matches. Back to the sword stand in to copy its rotation. So right click on rotation, copy. Right click rotation and paste. So now what we want to do is we want to duplicate our sword rest transform and call it sword active transform. Compile real quick to have access to it. Can't parse default value. Compile again. Oh, it's because I duplicated it and it tried to bring over values with it. It'll just zero itself out, just recompile if that pops up. So now what I'm going to do is I'm going to take my sword and kind of rotate it in a way that might look like somebody was striking somebody in front of them. Let's see how that looks in. A little strange. It'll look better when we change it with the real sword, but let's just go ahead and use this for now. So we'll copy the location, paste it to our sword active transform, copy the rotation, paste the rotation, compile that, and we'll go ahead and go in here and set up the actual function of it. So when we attack, we want to make sure we're not currently attacking already so that it doesn't interrupt the animation it's already in. To do that, we'll add a boolean called underscore, or not underscore, lowercase b attacking. And this will be a boolean. The b comes in handy to help distinguish when booleans are used, and when you drag them out, the b is gone, so it just says attacking. It's nice. So I don't know why I deleted it. I'm going to grab another one out of there, holding B on the keyboard and left clicking to get a branch, plugging that in, and if attacking is false, as in I'm not currently in the midst of an attack, then I want to set it to true. Then we will add a timeline right here called attacking, and we'll plug this into the play from start so that whenever this timeline is fired, it always goes to 0 and fires through, instead of, because if you attach it to play, it'll fire through one time and then register. It'll be like never rewinding, essentially. So for this one, we want to use play from start. Double click and open it up and set its length to about 0.15. That'll work. A nice quick little slice through. Then we'll add a track, not a vector track, damn it. We'll add a float track. I'm going to call it alpha. And what the alpha does is it measures the playthrough on this side, so whatever the timeline is at, what percentage it's at, it moves that through the alpha. So we'll right click and add a key at time 0, value 0. Right click, add a key at time 0.15, value 1. Zooming out with the scroll wheel and box selecting. To get both of them, we can zoom to fit horizontal. Right click, key interpolation. This is how it moves from one point to the next. Right now it's just a straight line, so it'll just be a constant increase rate. Using this auto gives it a nice smooth in, smooth out, so it kind of jumps to it and then smooths out. I like the way it does it. Back in the event graph, what we want to do is we want to take our sword stand-ins transform from A to B across this timeline. So I'm going to grab my sword stand-in and set relative transform. So the relative transform is its current position in relation to the character blueprint. If you do world transform, it'll take its position in the world and then update it. But relative just makes it move according to where it's at in this blueprint. So we're going to update our transform to the new one. And the way we're going to do this is with a lerp, or a linear interpolation. Lerp sounds more fun to say though. So dragging off new transform, I'm going to type in LERP lerp transform. This will take in two functions and then an alpha, not two functions, two variables and then an alpha, and it'll move from A to B according to, yeah, just like that. So I'll take my sword rest transform to A, my sword active transform to B, and the alpha to here. So if we compile real quick and jump in, I can swing it once. Oh, that's because it sets attacking to true. So after it's finished, let's set attacking back to false, just for test purposes. Yeah, so now I got a whacking stick. Bam, bam. Alright. So now we don't want it to just stay there at that position. We want it to, once it's done, back up. So what we can do is we can copy all of this. Control C, Control V to copy it and paste it, and then on the finished, hit reverse from end. This does the exact same thing, just make as the play from start, just from the opposite end, so it just backs it from 1 to 0. So it'll go down, back up, and then once it's finished, then we want to set attacking back to false. Blam. And that's how we can have our sword attacking. Now if you want to fiddle around with timeline positioning, not positioning, but length, to get the real feel you want, like maybe you want it to attack faster and then retract slower, like they're really putting it into the attack, then you would just kind of shorten this or lengthen this, whichever way. Like if I went in and added this to 0.25, I would have to go in and find my end point and change its time to 0.25, but the auto interpolation stays. So we compile. So now it's kind of got a little bit quicker down than it does on the up. Yeah, I kind of like it. I'm going to leave it. Save everything real quick, and now let's work on some blocking. So this is not completely done yet, but we will come back to it in a moment. So this is our attacking function. Now let's set up the blocking function. We're going to do the visual side of it, and then we'll go back and add the actual attack tracing side of it. So let's get our block action event. And we're going to do something fairly similar. We're going to affect our shield stand-ins transform. Actually, just the location really for this one. Based on yet another timeline. So when we pressed, we want to see, are we currently attacking? Because if we are, then we can't really put the shield in front of us. So are we attacking? Remember, you can add a branch with a B and a left click. If they are not attacking, then we will say that they are shielding. So B shielding for a new boolean. So block on pressed. If they are not attacking, then they are now shielding. And the reason we're doing this is so we can go back and add on to our attack function to limit it if they're shielding. So we will add another timeline called shield block. And for this one, instead of play from start, we're going to do play, because this one will be on, it'll be held. So when we push the button, it'll play through, and then when we release the button, it'll back up. So let's add in, let's double click to open up that timeline. Length will be 0.15 also. For now, we'll see how that looks. Let's add our float alpha track. And same thing as last time, right click, add a key, 0 on the time, 0.15 for value, no, 0 for value, 0 for the first one, my bad. For the time on the second one, 0.15 and 1. Box select both, zoom to fit horizontal, right click one of them, auto interpolate, compile. Back into our event graph. What we're going to do is the same thing. We're going to take our shield stand-in and we want to set relative location. So this works kind of the same way as a transform, except for since we're not affecting location and rotation, we can get away with just pulling out a location. So for this, we will need two shield variables. Shield inactive, it will be a vector, because this is how you measure locations on the axes and stuff like that. So we have a shield inactive and then one more shield active. It was underneath, but it added. So we have a shield inactive and a shield active. We're going to lerp between the two of those. We have not established those yet, but we're just going to go ahead and plug them in. So we'll go from shield inactive to shield active according to this alpha. And now let's get our actual location. So for the shield, where it's sitting at right now, I'm going to copy that into the inactive. Paste. And then for the active, let's see. Let's kind of minimize this again. That looks okay, maybe? Looks alright for now. So we'll just copy that location and then paste it into the shield active. And then let's take a look. Oh, I didn't do the release, although it is very quick. At 0.15, probably too fast. Let's change it to 0.35. Then we'll grab this and change its time to 0.35 also. Let's go ahead and do the unblock also. So on the released side of the block, we want to add one more branch and see if we are currently shielding, because that means that we've pushed this successfully because we weren't attacking. If we are shielding, then we want to set shielding to false and then reverse this. It's just moving straight across. It doesn't look that good. Let's go back to our shield stand-in. Get our shield inactive location and paste it back so that we can see its starting position. And let's just drop it down maybe a little bit. And that put it at -40. Alright, so -40 on the Z. And it's got a little bit of a lifting motion now. Maybe moving it up a little bit higher would be better. If you're having trouble getting it to position exactly where you want it, you can affect the grid movement by clicking this 10 right here and changing it, or completely disabling it to have precise exactly where you want it movement. I'm going to leave it where it's at. Let's see, it's at -40. Actually, for the shield active, I'll make it -20. No, -25, not 35. So just punching in -25 right there. Lifts it up a little bit more. That'll be good. So let's go back and block our attack off. So if I click to attack and try to activate my shield at the same time, doesn't work. But if I have my shield activated and try to attack, it works. Since the shield is going to nullify all damage, we don't want that to be able to do. So back up into our attack function. We want to make sure that they are not attacking or shielding. So what we can do is just take this attacking boolean, get an or boolean, and this will compare two values and make sure that they're both negative, or that neither one is true. So now when I come back in, I can't attack as long as I'm blocking, and I can't block as long as I'm attacking. So that's working as intended. But I don't want my character to be able to just run around full speed as they're blocking. So we're going to move all this way a little bit, and we're going to add in an actual function. So over here in your My Blueprint functions, we're going to add one called adjust move speed. Now this will take in an input over on the details panel. Click this to create an input on this function. This will be speed, and we're going to change it from a boolean to a float. Now let's grab our character movement out of our components tab, and we want to set max walk speed. We'll plug that in right there. Plug this speed into whatever our new walk speed is going to be. And then now anywhere we need to move, anywhere we need to adjust our character speed, we just drag that out, punch in the number we want. So on block pressed, when they start blocking, I want to half their speed. So 450 is the normal, 225. And then when they release, I want to set it back to normal. So we'll go to 450 here, just to double check and see how that looks. Decent. Alright. Got our character in and moving around. And they can slow down when they're blocking. So we'll block this out. Shielding. We'll move that up right here. We'll grab both of these. We'll grab one of them at a time, apparently, because it didn't work. Compile that, save everything, and good deal. Alright, so now we are going to start needing to set up our characters' the data side of the attack. So we have the visual in place. Now let's go back and make it to where when they go through the attack, it actually strikes. So we're going to set up another function called attack trace. What this will do is it'll take our camera and fire a line out into the world and see if it hits anything within a certain range, and if it does, it'll apply damage to it. So we're going to get our attack trace. Let's get our camera. Get the forward vector and the world location. Then we're going to do a sphere trace by channel. Not the multi-sphere trace, but the bottom one, the sphere trace by channel. We'll plug this into that. The world location is the start because we want it to start at our camera. Then we're going to move forward a certain number of units in front, and then that will be where it ends. So from the forward vector we need to multiply, so Shift 8 will get you the multiply node. Right clicking on the B vector, you can convert the pin to an float, and I'm going to set it to like 125. Now from the world location, we need to add from our world location this many units forward. So we're going to go Shift and the add or equal sign, plug the float multiplier in, and then to the end. Now for the radius, I'm going to do just 20. And for the draw debug type, I'm going to select for duration. This will actually let the trace channel be seen in the game. So now we need to actually tell our attack event to call this. So inside our attacking function, right here on the finished as it's registered, I've attacked, we can call our attack trace here for now, just so we can kind of see. It seems to be a good enough distance. Maybe a bit too far. We go into our attack trace. Maybe set this to like 100 instead. That'll work. So I'm going to right click this 100, promote this to a variable called attack range. I'm going to right click and promote the radius to attack radius. Suppose we really could have made those local components because we're not going to change swords. But if you're working on something and you're going to have different swords with different reaches, then you can just affect this range to essentially change how long your sword reaches. So now on the sphere trace out hit, we want to break the hit result. So when that red line crosses anything, it'll turn green. Like that. And that registers it has hit something, and it can get the data from that hit. So we're going to get the hit actor. First we're going to add a branch here. B left click and attach it to this return value because this determines whether or not it was a hit. Then we're going to get the hit actor and see if it is valid with this question mark. So if there is a hit and the hit actor is valid, then we want to apply damage. What the isValid node does is it'll check to make sure there's an actual reference before it. Like let's say an actor was deleted like right after you hit it. It wouldn't be able to apply the damage effectively because it would no longer be a valid reference. So this checks to make sure, okay, it's still in the world, now apply the damage. Don't try to do something to an actor that doesn't exist. Your computer doesn't like that. So it's always good to have valids and branches and double checks and triple checks and all that jazz. So now for the base damage, let's just say 5. The reason I'm punching it in like this is because when you right click and promote it to a variable and then compile, it'll automatically have it set at 5. So whatever you put in, then you promote, automatically gets set, just like the attack range and the attack radius are automatically set also. So let's save everything real quick. So now we need a way to actually check to see if we're doing damage. So I'm going to create a new folder called enemies. Double click and open it. I'm going to right click and create a blueprint class of a character called knight_BP, and this will be our enemy stand-in for the moment. So for the mesh, I don't think we have any. Kinda. What is this? Why is he like that? Why is it invisible? I don't know, but we're gonna go old school and we'll get rid of him. We'll add a sphere, not a sphere, a capsule. Where is it? Well, every other game engine has it. Let's just add a cylinder. We'll just add this for now. So I'll drag out my enemy, my floating cylinder, so that we can actually have it in the world. And in the event graph of it, I'm going to delete all this, right click, and on any damage, event any damage, we're just going to print a string. This is where you can print out text to the console so you can kind of see what's happening. I'm just going to print out the damage that was taken. Oh. Whoa. Well, he's taking damage. That's right, you don't come back. Alright. So he's taking damage. So what I have noticed is I forgot to set the sword back up. So I'm going to get my sword rest transform, copy the rotation of it, and put it back on my sword stand-in. I know it's happening. It's because I have collision still on these weapons. Sorry about that. I was trying to gesture to my weapons. I don't know why. So what we can do is we can just go in and actually, under the collision, set to no collision. Shield stand in, do the same thing. Because we don't actually need these to block any hits. These are just visual representations, and then the data is handled through line traces and checks and everything like that. So let's save everything real quick. And let's set up our player's damage function. So we'll do an event any damage, so that whenever the player is hit, we can tell it take damage. So minimize that. So for that, our character will need a health variable. But not just one, we will need two, because we'll have a current health and a max health, so that our health bar later on will reflect that accordingly. So we're going to do current health. This will be a float. And then we'll do a max health. So let's say their max health is 100. Then the current health would start out at 100, and as they take damage, this one would be the one that changes, but this one stays the same, so that when they heal, it has a cap. So when they take damage, we want to take our current health and subtract from it how much damage we've taken, and then set our current health to that new amount. But only if, so we'll add a branch right here, they are not shielding. Because if they're blocking, we don't want it to do anything. But if they're not blocking, then they'll take damage. So from the current health, we can check to see the new amount right here, so we want to see if it is less than or equal to 0. We'll add a branch with a B left click. Plug that in right there. And if it is less than or equal to 0, then we'll just open level by name. What this will do is we can punch in the name of the level we're in, and it'll just basically reload itself. Instead of punching it in, we can get level, or get current level name. Just like that. And then convert string to name. And then when we take damage and do that, boom, it'll reopen, reset everything back. So I'm going to set up just a quick little event. I'm going to type 1 on the keyboard to get this keyboard event, and I'm going to apply damage. The damaged actor will be myself, and the damage will be 25. Since my health is 100, I should be able to click this on the 4th time. It'll reset the level. So let me move over 1, 2, 3, 4. And I've reset back to my original position. If anything had moved in the level, anything I gained, it would also go back to normal. So we can delete that because that's working. We are going to replace this with a knight in just a little bit, but for now, let's work on the rest of this. So this is our damage function, so box select C to comment that out, and that's damage. Come on, there we go. So now another thing we will need is an interact trace so that we can open doors, chests, pick up keys, what have you. So right click, and we're going to set up our interact action event. And kind of like the attack trace, we'll do similar, but this will be our interact trace. So we will pretty much do the same thing. We'll get our forward camera, get its world location, and its forward vector. And then we'll do a sphere trace by channel. Actually, for this one, let's do a sphere trace for objects, because I'm going to show you how to add a collision object channel. So we'll take our world location as the start. From our forward vector, we'll do the same thing, Shift 8 to multiply it, right click on the bottom pin to convert it to a float, and we'll say 150 because we might need to pick up stuff off the ground. From the world location, let's get an add operator, plug in this multiply into the B, and then this into the end. For the radius, it'll be 20 also for now. Now the thing we have to do differently from the last one is set an object type. So right here we can go make array, and then you can add as many different types of object collision types that you want to. The way you can add object collision types is in the project settings. Just search collision object, not object. Let's see. Object channels. So engine collision object channels, you can have up to 18 custom ones. We're going to add a new one called interact that will automatically default to blocked. Now back inside our player blueprint, we'll compile real quick, and now we can select interact. So anytime it hits an interactable object, it'll be able to register its fire events. So just like last time, we'll add a branch to double check and make sure we have hit something. We'll break this open so that when we have hit something, we can tell it to do something with the actor it hit. But right now we actually don't have the thing we need. So let's save everything. Go back into our main function, main folder. Create a new folder called interaction. Double click and open it up, and we are going to create, under the blueprints, we can have a blueprint interface. What a blueprint interface does is it allows you to send messages and information back and forth between different blueprints without having to create hard references. Hard references are very, like, if you have too many of them, they'll have a big performance impact. Whereas this will just kind of get a general assessment of what you're trying to send the message to, and then just communicate a little bit of information across. So we'll add a blueprint interface, call it our interact_BPI. Double click and open it up, and the very first function we will call interact, just like that. Now we're going to add two more functions. This will call pickup key, and then this will be pickup gold. Now you could separate some of these out and make it to where the player has their own player input BPI, interactable objects have their own interact. For the sake of this project, one is enough since it's a small scale project. But if you wanted to add more later on, you could fairly easily do that. So if our interact trace has hit our interact object, we want to get the hit actor, double check and make sure that it is valid. It's always important to have checks and balances and all that jazz. And if it is valid, then we will just do our interact message right there. That way, if we have a key, its interact event can say delete this key but register that your player has an extra one. If it's a door, then we can tell it do your opening animation, etc. So just as a example, let's go back into the modeling mode. I'm going to set out a donut or a torus. I don't know why it's called a torus. And I'm going to set this down to like 5, 5, 2. Make it really small so that we can just set it on the ground. We'll replace it with a key mesh later on. And we'll accept that. Actually, what we could probably do, let's see. I don't know enough about this one just yet. See what happens if you... Ooh, buddy. Cancel. Alright, we'll just use this. Browse to asset. We'll just call this key stand-in. Go back to our interactions. Let's add a blueprint class of an actor. This will be our key underscore BP. Double click and open it up so that we can, in the components tab, add a static mesh. That will be our key. Over here in the details panel under static mesh, we can click the drop down and go into key stand-in. It's a small little donut, but it'll work for now. Now we need to affect its collision, so under collision presets, instead of block all dynamic, we'll go to custom, and then we can set its object type to interact. Now what I usually do with interactable objects in the world is I always tell it to ignore my player's camera. This doesn't really matter so much in this first person game because the camera is not able to be interacted with very easily. I'm used to making third person games, so anytime you're having something, if your game is third person and you're having issues with your camera jumping around as you're blocking into stuff, just make sure that it ignores the camera and it'll fix that. So if I tried to jump out here and pick this donut up, it's not going to work because that's just the mesh. Let's set that in the world. You can tell if it's a mesh or not because it'll have this little white circle thing when you zoom out. That thing. Just the meshes don't have those. So in the key BP under class settings we can apply our interfaces. So class settings right here at the top, inherited interfaces. I think it used to be up here but now it's down here. We'll add our interact BPI and then it'll know what kind of messages it should expect to receive. So we'll get rid of all this, and if you double click the interact event over here, it'll automatically add the little node. And on event interact, let's just print a string for now that says found a key. Never underestimate the power of these print strings. They can be good for debugging, prototyping, testing things out, all that stuff. So so now that we have our interact function, our input action interact, let's actually call that interact trace, otherwise we're just walking around doing nothing. There. Oh no. I forgot to turn the thing on. But found a key, it's working. So if you want to be able to see the line, let's just go into here for duration under the sphere trace for objects. This works. Found a key. That's a good pickup range. Maybe too far. But you know what? It's fine for now. And you'll see it doesn't interact on anything else. Only things that register as having the interact object type. So now what we can do is we can actually add a variable to our player called keys or key ring, whatever you like. Change it to an integer, leave it defaulted at 0, and then when you're interacting with a key, we can get player character. So instead of having to cast over to the character and then automatically set that they're getting a key, we will get player character and call the pickup key message. And then after it does that, we'll just destroy the actor. So we can go into our player blueprint under the class settings and add that interact blueprint interface here also. So interact BPI, compile that. Now we don't need the interact function, but we can use the pickup key function. So when we pick up a key, we're going to take how many keys we have, so I'll get that variable, and then we'll just add to it. So instead of using the add, we'll actually just increment, which takes whatever number it is and adds 1 to it. So we'll increment it and then set it. Or does it increment and set at the same time? Let's do a print string, because right now I can't. I think it automatically sets it after it increments, so let's find out. Yep, I got 1 key now. Okay, so we don't have to do a set, we can just do an increment. Sweet. So let's save that. So we can pick up a key. Now let's set up a door. Now I know this all looks like crap. We're gonna go back and replace everything with the dungeony stuff in the part coming up. But let's do a door. So interaction, let's do a blueprint class of an actor called doorway underscore BP. Double click, open that up. We're going to add a static mesh called door. And for now we're going to use just a cube, but we'll shrink it kind of like that. That's too much. Let's do a 0.1. Raise it up and then move it to the side. So we'll set our doorway right here. We can get a size comparison. It's not very good. So let's do 2 by 2. And kind of line it up as best we can. And it looks better. So now for our doorway, we want to set our door object collision types. We'll set it to custom. This one interact. And I'm going to leave it to block the camera because a door probably would in a game, you would think. But on its event interact, which we haven't set up yet, let's go into the class settings and apply that interact BPI. Compile. Double click to add our interact BPI. Now the way we want this to do is we want to check to see if it's already in the process of opening, and if it is, kind of ignore input, but if it's not, then it opens or closes depending on whether it's open already. So we're going to add a boolean be opening, or actually, you know what, maybe something better to name that would be moving, as in if it's moving open or moving closed. So I'll add a branch on the interact to see if it's currently moving, and if it's not, we will set that to true. Then we'll add a branch here to see if it's be closed. So just to make sure that we'll default that to true. And if it's true, then we will set it to false. And if it's false, we will set it to true. So kind of similar to how we did the sword and shield movement, we're going to add a timeline here called door open. And from the top one we will hit play, and from the bottom one we will hit reverse. What we want to update is the relative rotation of the door mesh. So we'll do relative rotation. We want to do the set relative rotation. We'll hook this to the update and we'll lerp this. So right now the relative rotation of the door is 0, 0, 0 across the board, and we want to do -90. Now you notice that this is kind of rotating in the center, not how a door would. The reason it's doing that is because of where the pivot point for this particular mesh is located. When we make our door later on, we're going to set the pivot point to be over here, so when it opens, it'll actually swing appropriately. But for now, it'll just it'll have to look a little weird. So I'm going to set -90 into the B value. I'm going to add a track, a float track, say about 1 second long. So add the float track called alpha. Right click at the beginning, add a key, time 0 value 0, right click towards the end, add a key, time 1 value 1. Box selects both and then hit this zoom to fit horizontal, right click, auto interpolate. And then we'll plug that alpha in right here. And we should be good to go. Oh, but once it's finished, we want to set that it's no longer moving. Now there might be a little bit of a wonkiness. Hopefully not. There we go. Now our door opens and closes. Again, that'll be fixed later on to look more appropriate. But now what if the door is locked? We can do just a very quick, very easy branch at the very beginning. We'll do a branch. And we'll do a B locked. And if it's not locked, then it can open. But if it is locked, then we'll just do a print string for now that says find a key. So right now it's not locked. Let me go into my doorway and set that locked is true. Find a key. Now that's great, but what if you want to have doors that aren't always locked or always unlocked? What we can do is we can actually click this little eyeball right here to make this parameter visible out in the editor. So I'm going to set the default to being unlocked, and then with it selected, you can see over here in the default now it has a locked or an unlocked option. So if I duplicate this real quick and say that the one on the left is locked but the one on the right is not, then I can run up, open the one on the right but not the one on the left. So one door, lock it or unlock it as you please. So that's great, but I have this key over here. It's this donut key on the floor. How can I use that to unlock that door? We can go into our Interact BPI. We'll add two new functions called check keys and use key. And we'll do unlock door also. So when we check keys, what we want to do is we want to reach into one of these actors files and rummage around a little bit and then pull information out. So we want to pull an output. What we want to check is to see if they have keys. Have keys, question mark. And it'll add this return node with that. If they do, then we want to use the key and then unlock the door. So in the doorway, if it's locked, we want to get the player character and run our function of see if they have keys. Nope. Have keys. Has keys? Which is it? Oh, did I forget to? You might need to compile, because that's usually the problem if I can't find what I'm looking for. Has keys. Check keys. Also helps to call the right message name. So it'll add this little function node that we can use as a branch trigger thing. I don't know what to call it. But if they have a key, then we can say use key and then sets that this door is unlocked. We actually didn't need the unlock door. We can just do it right here. So compile that. And we'll grab all this and move it out a little bit. Compile that. If you want to add your print string right here that says grab a key or whatever, that's fine. Now over here in the player blueprint, you'll see that they have this grayed out event interface thingy. If we double click and open it up, it creates its own little function up here. What we want to see is if our keys integer is greater than or equal to 1. You can do this as a greater than 0. And let's just do that, probably easier. So let's do just greater than 0. Plug that in, and that will register our Boolean. This is how we can go from the doorway to check a Boolean variable for our branch over here. So back in the event graph, if they do have a key, then we're going to be using our use key event. And we're going to do basically the same thing as this, except for we're going to decrement, subtract 1. Just like that. So let's say I have 2 locked doors here, and behind this first one, this first unlocked door, is a key. So now I can come in, open this door, grab my donut key, I got it, open my door. But oh no, now I need another key for that one. So you can go find another one. If I just drop one right here. So open my door. Click that. Open my door. Still locked. Now we got locking and unlocking doors. Good deal. So now we have almost everything ready to start working on the visual side of it. To start with, I mean, we're still going to fix this dude up, but let us add in a gold bag. So let's just use a let's go into the modeling feature one more time. We'll add in a cone. I'm going to make it very small, so like 25 tall, 5 in the radius, 10 in the radius, 15 in the radius. That'll work. And that's fine. This will be my gold bag stand-in. So I'm just going to add another blueprint class of an actor called goldbag_BP. Double click and open it up. go find that cone, browse to asset. F2 on the keyboard will allow you to rename without having to right click. This will be gold bag stand-in. In the gold bag, we'll add the static mesh. Just like last time, we'll go into its collision properties and change it to custom. Change its object type to interact. And now in here, we'll go into the class settings and add our interface. So interact BPI. Compile real quick so we can actually have access to it. On event interact, we will get our player character and call their pickup gold message. Crap. Plug that in right there. And then just like last time, we'll destroy this actor. Now in our player blueprint, we have our pickup key, use key. Let's add in our pickup gold event. And we're going to need another variable, so we'll grab one called gold, leave it as an integer. And when we pick up gold, we will get our current gold. We're going to add to it, but we're not going to add a set amount. So I'm going to do a random integer in range. That way we have a little bit of variety. So I want it to always give at least 5 and at most 20. Seems like a big window, but it's fine for now. You can customize it to your heart's desire. So every time we pick up gold, we'll just do a print string at the end of it that tells us how much we have now. Now since we're not incrementing or decrementing, we do actually need to add the amount to it and then set it to the new amount. So we'll take the gold, add a number to it, set it, and then register that variable. So let's try it out. Let me add in a few of these real quick. It ain't registered. These are just the cones. These are not the blueprints. Alright, so let's add in the actual gold bags. The blueprint and not just the mesh. Got 13, 25, 35, 48. Not bad for 4 bags. Of course, you can customize those and make them however much you want. Again, this is just the stand-in kind of blocking out phases also. Now is when you can really play around with values. So let's save everything. And I think we're ready to go ahead and start over into Blender to start doing floors and walls and props and all that. And then we'll come back for the night at the very end. So let's head on over into Blender. I don't need you anymore. Let's head over into Blender. I'm gonna open up a fresh copy. Just let me get this set up real quick. Alright. Alright, so when you first open up Blender, and this is in 3.3 for mine, you'll have, of course, this starter screen. A on the keyboard to select everything. Double tapping it will deselect everything, but select everything. X on the keyboard, delete. Now I'm going to import an FBX of the Blender Mani that we set up in the preparation video. And this will really let us know how big everything will be in relation to the Unreal Engine. There's other ways of doing it with the numbers, I just prefer visual. So first thing we need is a floor. So I'm going to Shift A and add a cube. S on the keyboard for scale, Z to put it on just the Z axis, and 0.1. This thing is not registering all my inputs, but the Z is 0.1, just like that. Now S on the keyboard and Shift Z, and then 5, so that it can be 5 units. And you'll know if it's right because it'll be, well, it's 5 and 5 on the X and Y, but 1, 2, 3, 4, 5. And that's pretty much all we need for a floor. Now we just need to add a material to it. Luckily the polygon thing has a really nice floor on page 3, I think. Yeah, that's the one. And I'll apply it to the floor. You can't see it at all. Hang on. But if you hold Z on the keyboard and go to Material Preview, there it is. But that looks terrible. So we'll tab into Edit Mode, 3 on the key. Hey, it says 3 now. Why ain't you doing it when I'm registering stuff? Yeah. Alright, 3 on the keyboard will take you into Face Select mode. Let's select this top face with a left click. Right click it. UV Unwrap, and we'll go to Smart UV Project. And that makes it look a little bit nicer. Not too terribly worried about the sides, because we'll be just linking it up. Now for the underside, we'll do the same thing, because the underside will also serve as our ceiling later on. But we can have a different material here. You know what, let's go ahead and do that now. Dungeon would have a different material on the ceiling probably, right? What is that? Bricks painted white. Maybe not. That's the wall, so I can't use that. Cliff. Yeah, it's not an underground place. Whoa, whoa, whoa. Concrete wall. Yeah, I'm gonna use this one, why not? I really should have planned which one I was going to use first. Anyway, now we have our floor set up while this is downloading. Let's just go ahead and tab out of edit mode, and we will add in a new cube to kind of use so we can set up our wall. So if I tap 1 on the number pad, it'll take me into orthographic mode from the front. I can bring this up to about floor level. And then we can snap to the grid so that when I push G and then Y and hold Control on the keyboard, not Control, Control takes it off the grid, I can move it back the 5 units all the way to the edge. I want it to be on the outside of the floor so that it doesn't overlap with the floor itself. Like if it was sitting on the floor but it was as wide, then once it got to the edge, this one and this one would be overlapping and it would have some texture cross, whatever you would call that. Oh, that's why it took so long to download. I did the high res. It automatically goes to the highest one. Anyway, with this selected, let's do X or S for scale, X for the red axis, and then 5. That way it's just as wide as the floor. Now I don't want it to be this far out, but also if I hit S, Y, and then scale it this way, it'll get thrown off the grid. So what we can do is we can go into edit mode, face select with the 3 key, grab this face right here, grab it with G, tap Y on the keyboard and then just move it up to about there. That way it stays in line on this side and isn't quite as jutting out. Alright, so now let's tap 1 on the number pad because I want to take that top face right there, G to grab it, Z to scale it up, and just put it a little bit more above the character's head. I don't want it to be like claustrophobic style. Maybe a little bit more. Because the character's actually going to be sitting a little bit higher. Their feet's in the ground here. Alright, that looks good enough. So I'm going to adjust the floor real quick. So with this one face selected, I can apply this material. And it only applies to the face I have selected. So Smart UV project. Ooh, that looks terrible. What happened? Control Z. Unwrap. That looks alright. If you're not happy with how that looks, what we can do is go into UV editing and then select the face that we want. Into material preview mode. We can scale it along the axes, just like if it was a mesh. That looks a little bit nicer. Kinda. Just, scale it how you like. That's looking fine for me, I guess. Let's go back into layout mode. Highlight this wall, and I'm gonna go back a page and apply this texture for my wall. I'm going to tab into edit mode and select the individual faces so I can Smart UV project it on both sides. And now we have our walls set up. That might still need to be a little bit higher, but this is fine for now. Let's get our floor and our wall in to Unreal Engine. So let's export FBX to the desktop. This will be dungeon floor. Oh, I already have one. I'm just gonna, this is my second time trying to record this. The first one's got corrupted. So we're gonna limit to selected objects over on this side. Under geometry, we're going to go to smoothing and do face. I'm just going to replace the one I have. The reason we're doing selected objects only is so it doesn't export the wall and the mannequin every single time. So let's export this out, grab our wall, let's set our wall back into the middle here, because the way things work in here is the origin is associated with the central area where all the axes line up in the middle. So I'll export my wall now. Once it's back in the middle, selected objects only, should be all the same, going down into the geometry, face. Alright, so we'll export the wall too. So back in Unreal Engine, let's go into our main, create a new folder called level assets Double click and open that up. We're going to create one more folder in here called textures, because we won't have any textures to begin with. But right now in the level assets folder, let's get our dungeon floor and our dungeon wall. Open that. We don't want this to be a skeletal mesh, but we also don't want it to create new materials. So do not create a material. Do not try to import any textures. So we'll import all. Now we've got our floor and our wall. Huzzah. But you might think, why did we bother texturing if we're not going to include them at all? I wish I could talk sometimes. What we can do is we can get those textures out of Blender, but if we tried to export it with those attached, it comes out not working for some reason. But what we can do is we can go find the textures. So we can open folder location, minimize that. These are the 2K. I just want the 1K. So I'm going to create a new folder on my desktop. Texture, tutorial textures. So I'm going to take all the 1Ks, so 1K, 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 normal, gloss, and reflection. All these into here. That's my wall texture, yeah. This is the one I used on the, so we'll open the folder location here. Let's get the 1K here, color variant 1. Oh, we can have another. Ooh, nice. It's got some variations. So 1K, 1K, 1K. Bueno. And then we need that brick texture. So I think that's on page 1 or 2. 2. So we'll open that folder location. Let's see, 2K, 2K, 2K. That one says 2K, but it also has a different file type, so I don't mess with it. But this will be fine. We'll just take all these right here. Now in our textures folder, hey, we're already in it. We'll import from the desktop. That's the wrong thing. We'll just import all of these. Just like that. Now what we can do is we can go, this is a wall, so we'll city, street, city, street. We'll right click, we'll select all the ones that are city, street, and create a material from it. It created individual materials. Delete them all. 1, 2, 3, 4, 5, 6. Create one material. We'll just select one of them and do a dungeon wall underscore mat. Double click and open it up. The one you select will automatically be plugged into the base color, so it's probably good to use the color texture for it. Then we'll hold T on the keyboard and left click, and we can add in the normal. We'll go find our city, street, basically whatever's associated with it for the normal. I think it's actually the alpha that goes there. Oh no, that looks awful. Now let's do another texture. Let's just go find this. Let's see, we have ambient occlusion, which is what AO stands for. Crap. Ambient occlusion here, so we'll plug in that one here, then right there. Not really sure what ambient occlusion does, but they include it for a reason, right? So we'll drop this down here. So let's find the gloss. Pretty sure this is roughness, so we'll T left click. With it selected in the content browser, it automatically applies it. So if you look, it's already at the gloss. We'll set that into the roughness, but not with that. Let's try the alpha. That looks good. That looks dynamite. And now for the specular. What if this one goes into the specular too? Let's just see how that looks. You can kind of, oh, that looks good. Yeah, I like that. I'm digging it. Alright. That looks dynamite. Alright, so that's our wall. So let's go into our level asset. We can double click and open up our dungeon wall and apply that dungeon wall material, and it looks decent enough. Let's go through and kind of delete everything for right now. Get rid of the keys, the gold bags, this version of the character, that donut. Get rid of this floor. We're going to get rid of all but the last one, because I'm going to use it to place that one on top of. So the beauty of having that done the way we did this floor is now it'll snap. So I've increased my grid snap value to 50, and if I alt left click, it automatically lines up perfectly. You could probably do 100 also. But 50 seems, oh, 50 seems good enough. So now you can go through and just kind of set up whatever floor plan you're going to want. But that's good enough for now. Let's actually get the floor textured so it doesn't look like crap. So back in the textures. Down here to the cobblestone. So this is the color. So I'm going to right click and create a material from this. This will be dungeon floor underscore MAT. Double click and open it up, and we're going to do the same thing. So I'm going to browse to this asset so that I can find the normal map. T left click, put in the normal. Let's see, displacement, gloss. The gloss was the roughness and the specular, so we'll do this one. Is that the gloss? That's the gloss. Alpha for the roughness, RGB for the specular, and then ambient occlusion. Crap. T left click and plug that in right there. That looks dynamite. So now we can go to our dungeon floor, double click it to open it up, and for the top material we'll add our dungeon floor mat, just like that. The bottom will still be gray, you can't tell, but it'll still be grayed until we adjust that one. But for right now this is fine. So see, now we got our floor. Then we can start adding in, like this will be a room or something. Yeah, just like that. That's good. Then what we can do is we can add in walls. Let's go unlit so we can actually see. See, it lines up right on the edge. just alt click and drag around. What you may notice is if you try to do it from the other side, that it'll either be on the floor or too far away. But if you rotate it around, there is definitely a front side of the wall, but it's not a very big issue. You can just rotate it like that and it'll line up just right. See, that's what I was trying to avoid. It didn't do this last time. Well, what we'll do is I'll just turn off this scaling thing and we'll just kind of scale it out just a tiny bit. Just a tiny bit more. Maybe move this up just a tiny bit. Just kind of scale it out past the seam. It'll still be on top, but I don't know why it's doing it this time when it didn't last time, but yeah. Leave it to Unreal Engine to decide to do something different. But what we can do is we'll go through and we'll add a pillar. And that'll distract from it. Now if we jump in, the walls may seem a little bit small. What we can do is jump straight back into Blender. Edit this wall to be a little bit higher. That's quite a bit higher, but that'll work. Then I'm going to export FBX. This is dungeon wall, everything the same. I just export it. It'll override the last one. And then if I re-import my dungeon wall, yes, overwrite, and it automatically replaces all of them, just like that. So now we can kind of get a nicer, bigger dungeon. But it is kind of hard to see in our level at the moment, so let's fix that. Unlit's nice, but when you go into lit mode, this is awful. So what we will do is we're actually going to get rid of this directional light. Seems counterintuitive, but once we add the ceiling anyway, you'll see it won't affect it anyway. So I'm going to drop this down into place right about there. Set this back to 50 and then block it in just like we did the floor, just to give us a ceiling. So we'll take this wall way over here and then rotate it. Oh, 180, there we go. And then you'll see that, oh no, everything's completely black. But under here, under the place actors in this lights panel, we can get this rectangle light, drag it in, set it in about the center of our ceiling panel. So about here. And then we will scale it up. So source width, I want it to be as wide as the panel. You know what? Let's do this. just set it to the side. That way we can be 100% sure. So source width, I'm just going to say 950. And then for the source height, just match it to that. 950 works on that also. And then basically everywhere we've put our floor and ceiling panel, we can now put one of these lights. Select them all. If you have one thing selected and then you shift select something else, it selects everything in between. So I want to just drop this down to where it's underneath. I want it just kind of right underneath. So if we go into lit mode, there's nothing, but we can bump up how much light it's putting off with the intensity. And it's looking a little bit better, but I want it to look a little bit brighter. So we'll go back into our post-processing volume, and under this exposure, whatever the word was now, come on, compensation, we can bump this up to say 2, and it'll affect how much light is coming in. So I'm going to say 2 for now. I'm going to grab a skylight. That does nothing. But what we can do now is go down into our global settings. So under color grading, go into the global. For the saturation, I want it to be a little bit more colorful. So instead of being this gray and washed out look, I'm going to bump the saturation to 2. So you can select individual colors to accentuate. So like I want the blues to be more accentuated here, or the greens, or the reds. I want them all to be a little bit more vibrant, so on the Y, I'll just set it to 2, and they all kind of pop out a little bit more. For the shadows under saturation, let's say 1.25, but the contrast I'll set to 1. No, not 1.5. It's 0.85. 0.95. I mean, at that point, what's the point? So we'll just do gamma instead. It's 1.2. Yeah, it looks like crap. Just play around with values till you find what you like. I guess I'll leave that alone too. You can add scene color. So if you increase this scene color, it'll change the brightness. Or if you like having a kind of in-dungeon rave. Or you can add like a reddish tint. I'm not going to. I'll just go back up here to the let's say 2.5. Maybe if we go up to the attenuation radius, set it to 1500. Well, let's do all of them that way. Attenuation radius 1500. Oh, and we want to set them all to static lights, because they'll just be static. That's very bright. It's a very bright dungeon. Like, I am not on the edge of my seat at all. Let's do 1.5. That looks better. It looks quite a bit better. Let's jump in and see how it looks in game. It looks nice. Looks colorful. Looks vibrant. Lighting needs to be rebuilt. We ain't gonna worry about it right now. So let's go in and we'll add kind of a pillar real quick. Oh. Whoa. Ah. Alright, so let's Shift A to add a cube. We can turn off this snapping now. Number pad period will zoom in on the object you're trying to zoom in on. S to scale, Shift Z to only scale on those two axes. Let's move it out a little bit. Tab into edit mode, 3 to grab face select, G to grab, let's go ahead and turn the snapping back on. But instead, if you click this little drop down, we're going to snap to edge. What this will do is when I hit G to grab the top face, Z to scale it up, and then I grab this edge of this wall, snaps it directly to it. I can do the same thing on the bottom side. Yeah, it's be fine. Shift Y, do the same thing so that it's right on the edge of it and not bleeding into it. And I'm going to do the same thing here. So now it's perfectly in line with our wall. Let's Control R to add an edge loop and turn off snapping because that's annoying. G and Z to slide it down about hip height on the character. I can tell because his hands is here. And then we'll grab the faces. Shift clicking will allow you to select multiple faces at once. Alt E on the keyboard to extrude individual faces. Oh no, extrude along normals. And then moving up, we'll extend them out, or moving down, we'll move them in. I want to move them out a little bit like that. So I'm going to right click, add another one about there, and another one about there. So grab this one with shift click, and then I'm going to do I twice on the keyboard to do an inset face. Doing it once will inset everything that's selected. Doing it twice will inset each individual face. Alt E to extrude along normals again. Pulling down this time to scale them in a little bit and add a little bit of a detail to it. And then we'll select this up here. Alt E, extrude along normals. And just add a topmost pillar piece. You can add it, you can detail it however you like. This is just run-of-the-mill type of thing. So let's see how it would look with, maybe not that one. Maybe that one? Use quick menu to down. Oh, it's because I moved it. Alright. I don't want to download a 3K. See, I still got the high res. Let's see how it looks here. Oh. You're looking rough. Not as rough as it is now. So let's go through and we'll just select each individual face here. We'll smart view project this one. No, we won't. We'll just unwrap it normal. So how I did that was just pushing the Control plus icon, and it increases your selections. That doesn't seem to work very well here. So we'll just do it old-fashioned, one by one. Man, I don't know what's up with Smart UV Project. It usually works great. I'm just gonna unwrap. Shift select, shift select, shift select, shift select. Unwrap. Same things, but what we're going to do now, what happened? I'm going to select all of these and probably apply a different material. Let's try this one. It looks decent. We can do the insides right here too. Crap, crap, crap. There we go. We'll unwrap them. Apply that one. Select the faces on the inside. Unwrap. Apply. Unwrap, apply. Now I'll leave that one, but this one down here, Control plus in order to increase. And we'll unwrap and then apply. Looks kind of weird. Let's see. Let's just do all of them. Apply. I went the hard way about this. Could have just applied this to begin with. And then change that one face. Let's see. Yeah, we'll go back through select, 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 select. Whatever you have selected, it will basically unfold it and lay it out. So if we went into UV editing, you'll see it's all kind of selected the same. That's how unwrapping works. So it'll take each piece, and whenever you unwrap it, like if we use Smart UV Project, then it makes it fit the whole page. Oh, that looks decent. That looks good. It has its hit or misses. But this is fine. That looks decent. Alright. So now what we want to do, we want to try to smooth the edges out a little bit. So let's do a Shift S, not Shift S, Control S. Not Control S, Control A. Control A is how you apply. So we're going, like if you change the location rotation scale, I'm going to apply the scale because I stretched it out a little bit. So we'll go under this modifier and we'll add a, where is it? Bevel. And it kind of adds a little bit of nice detailing to it, smooths out them edges, makes it look interesting, right? Except for here. So let's unwrap that and then apply that. That looks better. That's looking good enough. You can add more segments if you like. Yeah, 2 looks better. 2 looks nicer. And then right here in this drop down we can apply it. Alright, now let's see where it's set at. So right here is the object properties. Location X, 0, Y, 0. Because I want it to be right in line with the center. That way when we place it around it's easier to do so. So I'm going to export FBX. This is my dungeon pillar. And I'll export that to the desktop. We'll go into Unreal. I'm going to set this thing's scale back to 1 across the board. So 1, 1. And then we will have that. But when we import this pillar, import, then we can kind of position it where we want to. So like if we wanted it on the edge like that. See, negative 145. Negative 45. Yeah. I think. Oh no. So, negative 45 minus 90. Negative 135. Alright, that's got it. But now let's open it up, because we need to go in and change this. I'm going to use the dungeon wall material. No, that's the wrong one. It's the second one is the dungeon wall. And for now, I'm just going to use the... Oh, wait. No, wait. We got... What do we got in here? We got the wood, but what other kind of stone do they... Metal steel? Ooh. Yeah, that looks cool. You know what? I like it. I'm digging it. I'm using the steel. So, plug that. Let's see, drop it down to 10. Gonna go into unlit mode for a little bit. And you can set these on each seam if you want to. And then just kind of position them around 90 degrees this way. And then there's a seam, so 45 that way. Move it up right on the seam. Should have hit the back with a texture thingy. But we'll just move it into the wall a little bit further. That'll work. Now we'll grab all these pillars and move them down a little bit, because they were floating. But that looks about right. So let's jump in. And that's looking good enough for now.